And well, let me welcome everybody. Good morning. Welcome back to the Collision Hub webinar series. This morning we've got Sean Collins from 3M. We're going to be talking about structural adhesives for modern collision repair. So Sean's got a fantastic presentation put together for us. We're going to keep an eye on the chat room. If you have any questions throughout, please feel free to use that or the Q&A section, your choice. Or if you want to step in at some point, you can raise your hand as well, and we can try to answer it that way. So with that, Sean, I'm going to turn over to you and let you have at it.
Well, thank you so much, and thanks everybody for attending here today. This should be fun. I apologize if I have any little glitches here, but this is all new to me and a lot of other people, so we'll work through it. But this presentation is about structural adhesives. We obviously get just tons of questions on structural adhesives and adhesives in general. So we thought we would throw this together and try to answer as many questions as we can. So just to explain how this presentation is put together, I wanted to show some good video that we actually did with Kristen, and her crew did a fantastic job. Best in the world crew over there. They shot these videos of myself and another colleague doing some repairs on a 2018 Honda Accord. With all the nuances in that repair, all the different types of steels, all the complicated procedures, we thought we'd go through that and film that just to give you an idea of the real process, right? So it's one thing to do a demo on, little panels, demonstration panels, whatever, but this is actual video of working on genuine Honda parts. So I've kind of chopped that up and distributed it throughout this presentation. So I hope it doesn't confuse you, but I'm going to show a video clip, and then we're going to talk about a few things that may not even be totally related to that clip, but just related to the adhesives. Just so I could divide these clips up through here and just didn't show one long video. So there's about 25 minutes almost of video in this presentation. So I'm not going to bore you with a whole bunch of PowerPoint slides. I'm going to try to get through quickly with those, but just give you the information you need. So that's how this is laid out. And then it starts off, by the way, with a little bit of history as well with the structural adhesives. I do have some housekeeping things to quickly address, just the topics off limits, and I know Jason from Collision Hub here is very familiar with these as well. Your questions and everything else need to follow these guidelines. Anything that's inappropriate, we just won't address. So Jason will handle that. But pay attention to all these things on this screen that we want to try to avoid getting into any of those topics. It's also important, the information in this course is not intended to be a substitute for any OEM procedures. Okay, so you're going to hear me say OEM procedures over and over again. Feel free to sip a beverage every time I do that. It's probably a little early for that today, but you're going to hear OEM procedures a lot throughout this, but that's the world we live in, right? We can't get away from that. So just be aware, the video that you're going to see isn't a substitute for OEM procedures. We still want to go and follow those OEM recommended procedures. Also, just a shout out to the OEMs that helped us with some of this information and allowed us to use some of their stuff: Honda, FCA, Toyota, General Motors, iCar. So we worked with all these companies on some of this information and just got their permission to use some things. So we appreciate that. So again,
Hey,
the
Sean,
agenda, we're going to talk about just a quick history of metal bonding. Yeah.
Hey, Sean,
Yeah.
we're not getting your slides advancing here. So let's.
Uh-oh.
Maybe escape. Let me escape out there and try to come back and try it again.
Yeah.
Maybe stop sharing and then retry again.
So are you seeing the OEM screen with Honda and Ford, etc.?
We are.
Yes.
Okay. So the agenda, like I said, quick history, The watershed moment, which we all probably know in the industry, that involved the Honda Fit and a course correction after that, OEM recommendation examples, and then the hands-on video as we go here. And then we'll save some time for Q&A. So let's try this video out, see how this goes. Are you seeing that?
We got the title screen, Sean. Yep.
Is the video playing?
It is not.
You're not seeing the video play?
It was playing, but
it's playing.
lost
Yeah,
the
so here's the
audio.
thing, Sean. I think you got a bandwidth problem where you're at. So let's skip the videos and we'll just do the slides. Something's your internet speed's been choked down for some reason.
So audio, let's see. I got to turn on my internal.
Yeah, like you did before.
Yeah, I forgot where I did that though. Turn on internal mic or whatever that was. Where was that audio? We'll do this again and we'll get it straightened out.
Yeah, that's also a good idea. We can try that.
Yeah, because the video, like I say, that's the key. That's the whole point to this. But I'll go through this information here. So anyways, historical information on adhesives. The OEMs have been using adhesives during construction for over 40 years. It's kind of interesting, this picture I have over here on the right, showing that door skin bonding kit. I don't know how many guys were around long enough to remember those, but I was using that in a shop I was working at back in the mid 80s. And that was one of the first adhesives I really saw being used in the aftermarket, was that door skin bonding adhesive. And of course, there were obvious benefits to that, and especially, you know, the corrosion benefit living up here in the Rust Belt where we're at. It made a lot of sense to bond a door skin on rather than weld it, which really caused quick corrosion. And then MIG and mag welding was the predominant, you know, panel attachment of the industry forever. So a lot of us old timers grew up on that, right? All we did was mag weld and plug weld, and we didn't really deal with adhesives. So the adhesives were adopted by the industry, you know, due to those benefits, right? The corrosion protection, sound deadening benefits, sealing the entire joint, all those benefits that we get out of the adhesives. So slowly, the new preferred panel attachment method began to be accepted, and early on, there was typically some welding involved. Some of you may know, if you've read our instruction sheets from the panel bonding adhesives like 8115, you'll open up the instructions, you'll see a little diagram in there, and typically there are areas that were bonded on a panel, but then there were also areas that were welded. Like, for example, in a quarter panel, we welded in that tail lamp pocket just to have some anchor welds. So, you know, there's been a lot of evolving here as we go over the years. Now, this slide, I'm sure it's near and dear to Jason's heart. ICAR 1996, training had not yet developed, and we were still, you know, questioning the practice of bonding. But, you know, I hear guys say sometimes, well, you know, the whole follow the OEM is a recent thing. But if you look back to 1996, 24 years ago, ICAR was saying, hey, you know, whatever you do with these adhesives, you still need to follow the OEM procedures. And now we know early on with these adhesives, there was a period where it was kind of, we call it the Wild West, where guys were just bonding everything left and right. And of course, with, you know, recent litigation, those days are over, right? So we really need to follow those OEM procedures to avoid any kind of liability. So the statement here was that, you know, there's liability, and basically the instructions in the adhesive absolved the adhesive maker of liability if it was used improperly. So I know in our instructions it says it should not be used on rocker panels, frame rails, you know, structural parts. So that was a big deal there. If it was used improperly, you were not going to be covered for liability. And then the OEMs didn't have liability either if the adhesives were used in an improper area, okay? So again, the big statement here, it's important to keep in mind that the OEM repair recommendations will dictate when and if adhesives will become an acceptable method of repair. So all the way back 24 years ago, that was the policy. But again, a lot of people really didn't pay a lot of attention to that until there was a big event, right? So the OEMs began to respond to some of this use of adhesives as well. And Ford put out a statement basically saying they're not endorsing using adhesive to replace welds. If it was welded, they want it welded back on. And this again is in '98. They said it was okay for door skin, hem flanges, and the reason was because there was inconclusive test data. The testing had really just begun on these adhesives by the OEMs and by other groups. Insurance companies and third parties started to do some testing, but they really didn't have a good basis in science for the adhesive at that point. They also warned adhesive suppliers that some of their information was really intended for North America and wasn't global. So they kind of asked the adhesive makers to make that more clear. So then some more responses from the OEM in 1998. So you're seeing, just before the year 2000 is when all this was really starting to sort itself out. So Chrysler did not recommend bonding at this time. There was actually some bad news out there, some incorrect information out there about bonding some things on a Chrysler Sebring. They wanted to straighten that out, but also just, again, remind people that they should be following those OEM procedures. And then General Motors basically came out and said, hey, we're working on a position. This is something we're looking at, but we don't have enough information at this time, so replace welds with welds. So a little more just timeline here. So in '99, ICAR launched their ADH01 adhesive bonding training course, okay? So now we're starting to see a little more acceptance, a little more training here. In '02, General Motors endorsed metal bonding of outer panels. '03, 3M, we launched our 8116 panel bonding adhesive. And just a little refresher on that for some people. A lot of people are familiar with 8115, but they're not real familiar with 8116. And the 8116 was specially formulated to meet General Motors and FCA or Fiat Chrysler test demands. So what they required was an adhesive that if the panels ever do separate in a collision, they want those panels to separate cohesively. So if you can picture in your head, if you tear two panels that are bonded, you tear them apart, and you look at what's left on the bonding flange, if there's adhesive almost fully covering both sides of the flange when they're torn apart, that would be cohesive failure. But if you tear those same panels apart and all the adhesive ends up on one side and not the other, that would be adhesive failure. And the reason they thought that was important, if you can picture like a moderate rear end collision where maybe the rear body panel and the quarter panel flexed, and you know how energy travels through a vehicle, all the flanges and joints flex, and if those areas that flex separate and it's not noticeable and that panel doesn't need to be replaced, maybe it just needs a buckle repaired in the sail, but the panel is okay, but those seams are separated and all the adhesive is on one side and not the other, that would be open to corrosion and be a potential safety issue for the next collision. So that's why those two manufacturers specified an adhesive that fails cohesively, okay? So it's really important that you are using 8116 for those GM and Chrysler operations. And I'll get a little more specific on some slides coming up on exactly how they want that done because they're a little bit different. So then 3M, we introduced our ICAR Alliance training for panel bonding in '03. And by the way, we just updated that. So soon you will see a completely refreshed course, all brought up to modern everything, standards and all, for the panel bonding Alliance class. And that'll be available very soon. And then Toyota in '07 actually started to call out the use of adhesives on some of the panel repairs. So that was a big milestone where the OEMs started to open up and say, hey, you know, as long as you're using this stuff correctly, there are operations where we do prefer bonding in some applications. And if you look at the screen on the upper right picture there, you see that Toyota crib bulletin, and that's calling out 3M 8115 adhesive there. That kind of reminds me when I see that of how things used to be and how they are now. Where in the past, I worked at a shop where the boss came out one day. This was probably in the early 90s, and he said, "Hey, in my shop," or mid 90s maybe, "in my shop from this day forward, all of our wheel lips, wheelhouse areas are going to be bonded." And his reasoning was that if we weld them, they're going to corrode, and the OEMs weren't going to warranty any corrosion in that area. He'd be responsible, so his choice was to bond those areas. So back then, some shops figured if they did their due diligence and were comfortable with it, that they could do that, but that's probably not advisable now. I should say it isn't advisable now, right? So they really want us to follow those OEM recommendations exactly and not kind of stray off like they used to, just because of liability and the things that have happened recently. So you can hear me okay yet, Jason?
You're good, Sean.
Okay, just wanted to check that I'm not just talking to myself here. So this slide here is showing even more acceptance from the OEMs, where General Motors, I think this was about 08, came out and said, look, you can have a choice. You could weld on the truck box side. However, if you wanted to, you could also just bond that on. Okay, so they offered the option. So it's just another sign that the OEMs were kind of warming up to the bonding, and they saw the benefits. I mean, we all know the corrosion benefits are palpable. There's serious corrosion benefits there for the corrosion protection aspect, especially in corrosion vulnerable areas like wheelhouses, for example, right? So then this is where we see that industry course correction, we call it. So the collision repair professionals are increasingly aware of the need to follow these OEM recommendations. Part of that need is because we're starting to see a lot more people looking at these repairs after the fact, okay? So we're starting to see a lot more re-inspections. All these re-inspection companies are popping up all over the place. So, you know, you're much more likely to have somebody else look at that vehicle at some point after the repair, and we want to make sure we're doing everything correctly just to avoid the lawsuits. And, you know, it's not just physical harm to passengers, being killed in a car accident or injured in a car accident. It's all about diminished value as well. And, you know, that's a big deal too, where a lot of shops are having to buy back vehicles. There's a lot of litigation that we don't see. It's not public because a lot of times they may even have like a gag order where they can't talk about these lawsuits. So there's more of them out there than you think there are. So we just have to be very carefully. So in the United States, we're definitely transforming towards the OEM procedures, and they take precedence in the body repairs involving structural and non-structural metal adhesives. So just kind of some information on today's cars and where we're headed. Imagine there's vehicles now with 40 pounds of adhesives in the vehicle structure when they're built. If you think about 40 pounds, that's about a 5-gallon bucket full of water or adhesive, weighs about 40 pounds. So a 5-gallon bucket worth of adhesive in that vehicle between the flanges. So there's a lot of it in there. It's going to be hard to avoid from this time forward. You'll see maybe even sometimes multiple adhesives on the same vehicle, where in some areas they may have a traditional bonding adhesive, and then some areas they may use an impact resistant structural adhesive, which I'm going to address, and they're completely different things. So we have to really pay attention to which adhesive we're using. And then it's still very common to have some form of welding involved with these repairs. And that's why in the video that I have that correlates with this, we talk about some of that and how to deal with welding around adhesives and leaving a buffer zone where we don't get too close to the adhesives and things of that nature. So we have to be really pay attention to those procedures that will call out those that kind of information. And then if you look to the right here, you see that the BMW 7 Series in 01 had 33 linear feet of adhesive compared to the 2019 model with 500 linear feet of adhesive. So again, it's just something that we've got to be accustomed to dealing with. Just for giggles here, Jason, I'm going to try this video. It's a little different one. See if it plays at all.
Yeah,
You see
same
that one
issue,
at all?
Sean. Yeah, the same issue. No,
Okay.
no audio again. So
Okay, no problem. All right, so and again, we'll have all those videos available so you can view those. So the impact resistant structural adhesive, this was the big change just over the last few years. The impact energy is transformed into deformation energy. And by the way, that video that I couldn't play is an awesome video that really explains that well. So I'll try to do a good job of explaining that. But what happens, you know, a lot of people ask, well, how can an adhesive absorb energy? Okay, so it's not really the adhesive that's absorbing the energy per se, as much as what the adhesive is doing is it's got a little more give to it. So and there's other technology in that adhesive that is allowing the panels at the flanges to remain intact longer for a longer period of time, which allows the metal to absorb more energy as it deforms. So basically, it keeps the metal together, as if you picture a frame rail getting hit, it keeps the flanges together as that frame rail kind of accordions. So as that accordion shape takes place, that adhesive is allowing that flange to stay together and absorb more energy. So that's really the big advantage of those types of adhesives. And the video, what it does is it shows two what we call wedge impact tests. So what they do is we have two pieces of metal, and we have a drop tower where a big wedge comes and drives between the panels and separates them. And when you look at a typical panel bonding adhesive, what you notice is when that wedge starts to separate the panels kind of separate ahead of the wedge. It kind of blows the whole thing apart much quicker. But when you see the same wedge going through an impact resistant adhesive, what you'll see is that until the wedge actually makes contact with that leading edge of the adhesive, it will not separate. So it doesn't blow apart ahead of the wedge. That wedge actually has to separate those two parts, and it curls the metal as that wedge travels through there, and that curling metal is what's absorbing energy. So again, probably a little bit hard to picture, but there really is technology in that adhesive that allows the structure to absorb more energy. So it behaves like a buffer. The adhesive use will continue to increase. We're going to see more OEM certifications that are going to involve adhesives as well. We're going to see a lot more OEM approvals, and the approvals are coming fast and furious as well, or recommendations or call outs, whatever you want to call them. And then if you look over on the right again, you just see the increased use of adhesives steadily increasing as the newer models come out. In the video that was going to play, I talk about some welding issues, so we just want to caution everybody, but this is a good time just to remind everybody, you know, be safe when you're working. As a tech, especially when I got older, I started to kind of pamper myself with better and better PPE equipment, you know, better glasses, better welding helmet. I had a welding papper at the end of my career. So, you know, take care of yourselves, kind of pamper yourself, treat yourself good with this PPE equipment. You're gonna really appreciate that when you get a little bit older. I'm in my late 50s now, and trust me, had I not taken care of myself, I would probably have a lot more issues. So we just really want to take care of our bodies when we're working on these vehicles. That's the most important thing. So the video talked about applying the adhesive and making test welds. So I'll address that. This was a Honda procedure. So Honda has a very specific procedure for testing the welds. So they actually have you cut scrap pieces of metal and from the actual vehicle. So it could be scrap pieces from the panel you're cutting off, or if you have like leftover areas of the new parts that you're cutting off, like a sail panel area, you're going to cut those off and use those for your testing. And they have you weld these parts together in a kind of a T shape. Now this B-pillar we were working on had 3 panels. It had an inner stiffener, it had an inner B-pillar reinforcement, and then it had an outer B-pillar. And between the inner B-pillar reinforcement and the stiffener, there was adhesive for the repair. But then the outer B-pillar, just the outer skin of it, had no adhesive between those 2 panels. So 2 panels with adhesive, and then the top panel did not have adhesive. So it was a little tricky trying to get everything put together and have time to weld everything before the adhesive cures. And, you know, there were a number of issues that we had to address with that repair. But the test weld portion of that is very important. So you have to make those test welds, set them up like the OEM wants you to, and create those welds and make sure they pass. And I can tell you it was very interesting working on this vehicle, because when I was preparing to go down to Collision Hub and film that video, I was using our ProSpot i5, and I did not have the ability on that machine at the time to go in and set it manually. I needed a lockout to be able to do that, and I have that now, but at the time I didn't. And I didn't think it was that important, so I was welding manually. And when it came to welding that triple stack of panels together manually, it welded it only enough to be dangerous. Okay, so it spot welded them together, but if I put any force on it, it would break them apart. So that was a big eye opener that, wow, what am I doing here? What am I doing wrong? So when we got down to Collision Hub to do this, I made some more test welds on the machine that Kristen had, and it allowed me to go in and set the machine manually. And I can tell you it was a noticeable difference. You could tell that the hold time was much longer on the manual setting than it did automatically. So big heads up there, if you're welding with through adhesive with squeeze type equipment, consult that OEM information. And that B-pillar rocker assembly had, I think it had like 9 different weld settings just for that area of that vehicle. So in their procedures, they had what they called weld conditions. It would show you what the hold time was, what the squeeze pressure was, and what the current was. And you had to set those manually in order for that to make a good weld, especially, like I said, welding through 2 layers of high strength steel with adhesive and a 3rd layer without adhesive was a lot to weld through. And that's why it had to increase that weld time to be able to make a successful weld. So always look at that information. I can also, sure, yep.
What slide are you on?
I'm still on the video. It just shows the video of applying test welds, applying adhesive.
Okay. Slide 18.
Okay, so
okay.
I'm just sort of, thanks for pointing that out, Jason, because I'm just winging it right now, okay? Because I don't have the video, so I'm adding a lot more content. So I didn't mean to mix you up with that slide. So I have not advanced that slide for that reason, okay? So you're not missing anything. Thank you. So I did advance now to the OEM repair procedure and adhesive callouts. Can you see that?
Yeah, you're good,
I'll assume
Sean.
you can. So
yep, you're good.
Okay, thank you. All right, so yeah, just to finish up about the spot welding, I can tell you that, like Nissan, for example, if you just went and spot welded according to what you think, you're probably doing it wrong, because Nissan actually tells you to add 20 to 30% more welds during the repair. They also tell you to do test welds and measure the size of the tear out of the weld nugget when you do that. And it also has information on weld spacing and how far inboard on the flange you want to weld, and all kinds of very specific information. Okay, so if you're spot welding through these adhesives, consult that OEM information, dig in deep. Sometimes you have to go all the way in and follow certain hot links to get into that welding information. But most of the manufacturers do have specific welding information for weld bonding now. So don't just think you can just walk up with your machine, set it on automatic and weld it together. It's probably not the correct way. So really pay attention to that. Now, the screen you're looking at here is the OEM repair procedures and our adhesive callouts. So that's what we call it nowadays. We don't really call it approvals. Approvals are something that they use to approve adhesives at the factory for some factory operations. but call outs or recommendations are really the terminology we're using for the OEMs where they're making recommendations on which adhesive to use. Now, I don't want you to get confused by this chart either. Just because there's a check mark there, for example, the first one, Fiat Chrysler 8116, just because there's a check mark doesn't mean you can just bond everything on in that product line, on that vehicle line, right? So that means, okay, there are recommendations for Fiat Chrysler. Now we have to go into that procedure and see if it's recommended on this car, and if on this car, it's recommended on the panel I'm working on. So you need to drill down into the specific panel to see if that adhesive is recommended. But we put this chart together. It references the repair procedures and bulletins where you're going to find this. 3M has to meet rigid standards for these OEMs to recommend these adhesives. Okay, so everything you're looking at with a dot, it has a recommendation, and it has to pass strict testing. Now, one of my other presentations, I show one of the tests we did for one of the OEMs, and I just use it as an example because it's 119 pages. I think, 119 pages long. All the testing that had to be done to spec in that adhesive with the OEM. So we want to make sure we're using the correct recommended adhesive by that OEM. The other caution I want to have here talk about is equivalence. So there may be times when you go into an adhesive and they say use 8115, 3M 8115 or equivalent, and you really need to exercise caution there, because unless you have written proof from the manufacturer that that adhesive is equivalent, if you don't have written proof, now you are taking upon yourself to act as the chemical engineer and state that that adhesive is chemically equivalent, okay? And I can tell you, even as deep as I dive into these adhesives, a lot of times it's hard for me to even say whether an adhesive is an exact equivalent. And I would almost say it's almost like a fingerprint where every adhesive is unique and they all have a ton of different chemicals, and even the way those chemicals are dispersed throughout the manufacturing process make a difference. So really there almost is no such thing as an exact equivalent. So unless you want to take responsibility and call yourself the equivalency expert, I would just be very cautious about that. And personally, what I would do is use the adhesive that's actually named in that repair procedure, okay? Instead of just grabbing an equivalent. So just use some caution there. So 3M is the most widely recommended manufacturer of bonding adhesives in the repair industry. And we dug into all the procedures and verified that we're called out more than anybody else in these procedures. The construction materials and methods change all the time. This chart that we're looking at has changed probably 3 times in the last year as we've added more approvals, or correct myself, recommendations and call outs, okay? So this stuff is changing so fast, it's hard to even put anything in ink because it changes by the time you publish it. So always pay attention to the latest information. There's also more ongoing training and certification for following these OEM repair procedures. And, you know, of course, it's more important than ever, as we know. So a couple more things here on this timeline. And I'm going to show you some examples of repair procedures that are going to point out these kind of nuances or their preferences for these adhesives. So Honda, we're going to look at a 2018 model that uses 2 different types of adhesives. GM, we'll look at an example, FCA, and Ford. So let's look at these specific examples here. So this is a 2018 Honda Accord roof skin. And in this repair, they recommend the 3M 7333 structural adhesive, okay? So it's an 18 Honda Accord, and it's a roof skin, and they recommend the impact resistant structural adhesive, whereas another 2018 Honda, this happens to be an Odyssey, but it's another 2018 Honda, and it's also a roof panel, but in this repair procedure, they recommend the panel bonding adhesive, okay? So, and that's because one of the roofs was laser welded on from the factory, the other one was weld bonded on from the factory, or spot welded from the factory. So even in the same vehicle line, there's 2 different adhesives called out for their repair. So again, that's why we have to reference the procedures. So here's a GM example. In GM, within their line, they call out 2 different adhesives, okay? Now, the FCA example with Chrysler is all the same adhesive, which we'll see, but General Motors calls out for, and if you can't read the fine print, it's right here, but it's saying that for all of their bonding, for where the strength is very important, they're recommending the structural adhesive 7333, okay, except for door skins. So they say the other bonding adhesives are non-impact resistant, offer a low strength rating, and are only used for door outer panel hem joints. So the rule of thumb for GM, but again, always look in the procedure, things can change, but the rule of thumb is if it's a door skin, it's 8116. If it's any other bonding operation where they call out an adhesive, it's going to be the 7333, okay? So that's their general rule of thumb, but always look at the procedure to make sure. I mentioned FCA. So Fiat Chrysler, their recommendation is all the 8116 for 3M, okay? They call out some other products in here, but 8116 when using 3M, the structural adhesive is applied by itself or in conjunction with squeeze type spot welding, and is to be reassembled in the same manner as the vehicle build. So any situation where it's undetermined, whether it's structural adhesive or seam sealer, always default to the structural adhesive. So if you're not sure if it's an adhesive or seam sealer, FCA says go ahead and use the seam sealer. I'm sorry, go ahead and use the adhesive, which is going to be 8116. Here's just a look at their data sheet. So it's showing you where they're going to be bonding, but these bonding areas are then spot welded. Okay, so FCA is still recommending weld bonding is their preferred attachment method. It has been for a number of years. Ford, they also call out 8115. They're not recommending a structural adhesive. I do want to give you one other caution, by the way. I'm going to back up one screen. 2 screens actually, because sometimes some of these manufacturers are still calling panel bonding adhesives. They're using the terminology structural adhesives. So there's a difference between a structural adhesive, which could be a panel bonding adhesive, and an impact resistant or crash toughened structural adhesive. So when you see structural adhesive, usually they're talking about an impact resistant structural adhesive, but always check it out, because a couple companies I see, Ford and Fiat Chrysler are still calling it a structural adhesive when it's a panel bonding adhesive. So be careful about that. But here's Ford on the Mustang calling out the 8115. And again, it's a weld bonding operation with adhesive. We're going to skip this video talking about weld through coating and adhesive. But there are going to be a lot of operations where you're doing both. You're using adhesive and a weld through coating. So now I'm getting close to the end here, but I do want to discuss some of the things that are kind of detaily that you're going to want to pay attention to when you're weld bonding and using adhesives. So fit up is really important. So we see that some techs kind of develop some bad habits sometimes and get in a little bit of a hurry. And what they do is sometimes they'll start to attach a panel that really doesn't have good tight fit up at the bonding joints. And what happens there is if you're using the welder to pull the panels together as you're welding, what happens is when those panels get pulled together under stress, once that weld nugget area gets red hot and softens up, then those panels that are still springy are going to spring apart, and that's what blows a hole in those panels. So it's important to have really good fit up and make sure your panels are dry fit before you attach them. Make sure you don't have any large gaps, there's no tension on the panels, and get that good fit up before you start to bond these panels together. The other thing is very important is that clamping time. So when you see that they recommend a certain clamp time, how those panels should be clamped together for a certain period of time, make sure you're observing that strictly, especially if you're in a cold area, your shop isn't heated very warm. Some guys even roll a vehicle outside after it's been bonded together. Be very careful about doing that, because these are meant to stay clamped together at least 70 degrees for that stated clamp time. 8115 is 4 hours. 7333 is 8 hours, okay? 8116 is 6 hours, so they vary. But that clamp time is critical because what's happening is that adhesive is transitioning from a liquid or technically a paste state to a solid state. And somewhere in that transition, it goes through like a gel state. And once it gets to that gel state, if those panels are separated because you moved the vehicle or did something to disturb that bond, they're never going to blend back in together again, okay? In that liquid state, they will, but once you pass that state towards a solid and it gets separated, you're going to have a bad bond. So observe those clamp times very closely. Also, as I mentioned earlier, closely duplicate the number of welds and the locations. Some manufacturers caution against welding in the same location twice. Now, there may be times where you have adhesive between the two bottom panels and you're putting a third panel over the top. In that case, some of the manufacturers may recommend welding through the original location. Otherwise, you have adhesive insulating the two bottom layers. So it's all different by manufacturer. So make sure you're checking out those details in their information to know exactly how they want that done. The other thing, again, is having that 1-inch buffer area between anywhere you're welding and where you're bonding. So if you're bonding in a sail panel, up around that sail panel area where you're going to weld, leave that 1-inch gap between where you're welding and the adhesive. And in that 1-inch gap, you should also have some weld through primer for corrosion purposes. But don't put your adhesive all the way up to where you're welding. It's going to cause a disaster for your welding and be a big mess. So that's also typical here, and this is information by Ford that's kind of talking about the same thing, using that 1-inch gap between any weld zones. Now they say, and this brings up a good point, because Ford says in their information, welding can be carried out anytime during the adhesive curing process or after the adhesive is fully cured. Now 3M, we do not recommend welding through our adhesives when they're cured. And if you've ever done that and cut them apart, you'd see why. Because once they're cured and you weld through them, it just turns it to charred, burnt adhesive and does not work well. So, but the reason this is important is that it's important to follow the adhesive maker's recommendations. Now, I know we always preach follow OEM, but technically 3M is the OEM of the adhesive, okay? So this information you're looking at here is misleading, and that's why we say to defer to the adhesive maker's instructions for the actual application of the adhesive. Not where it goes or anything like that, but how it's applied to the flange, how you abrade it, how you clean it, what you should be applying it to, okay? So Honda says the same thing. Right in their information, it says, always defer to the adhesive maker's instructions. So that's a very important distinction. And this is a really good example of that, because you can see they were telling you to do something we would not want you to do. And the reason is they don't know, the OEMs don't know which adhesive you're going to choose for the repair. Okay, so they kind of give general instructions. So always default the adhesive maker's instructions for the application of the adhesive. Just telling you here, for weld bonding, follow the adhesive maker recommendations like I was just talking about, okay? Do not weld over existing welds, and this is FCA, but other manufacturers, again, may have some different information as far as that goes. Now the video I was going to play was talking about welding through that triple stack of adhesives. And again, we'll post these videos for you. But just to kind of wrap up here, you know, there's of course a lot of different factors and variables that can affect an individual repair. So, you know, you have to evaluate each specific application and refer to the OEM guidelines, always. Be aware not all OEMs deliver the same level of detailed information. Short-term OEM subscriptions are available. So if you don't have all the OEM subscriptions and you need something, you can go on and get a 1-day, a 2-day, a 3-day, in a lot of cases, subscription to their information so you have the right stuff. Of course, a lot of shops use all data. You've got the iCar RTS that has some information. So keep that in mind, along with just remember 3M, you know, is the most widely recommended adhesive manufacturer out there. So the key takeaways here, and I apologize for the videos, but we kind of worked our way through it. But adhesives have a long history in the collision repair industry. Always follow your OEM repair procedures and recommendations. Do your homework. Training and research are more necessary and more available than ever. Adhesive type and procedure may vary by year, model, and actual panel being replaced. And then again, 3M's more reference than anybody else. So hope that was helpful. And again, apologize for the glitches, but I think we filled the information as well. There's some more information here. If Ian, you want to quickly chime in and cover any of this other stuff here. It looks like we're getting pretty close on time. Maybe we have some time for questions. Jason, you could chime in as well. But Ian, it looks like you got control here.
Yep. Okay. Thanks, Sean. And thanks for sharing all of this information with all of our guests here today. So just in quick reference to the videos that we had some technical difficulties with, there is a link in the chat section that I posted. A lot of those were pulled from an industry night training that we did in 2019. So you'll be able to find the footage there if you are looking for that. So I just want to cover a couple of the digital resources that we have available for our shop partners out there. We've developed at 3M a number of tools and resources over the years. It's, of course, the intention is to help our body shop partners navigate the collision repair process. The first example here is pretty simple in that it's our website, right? 3mcollision.com, and there's a number of resources on this site. And specifically, I just want to draw your attention to our standard operating procedures here under that application section. So, these were, again, developed by Sean Collins and many of his application engineer counterparts within our company. And, as Sean mentioned, the OEMs are absolutely the experts in guidance on the repair process for their for vehicles. The 3M and other manufacturers were the experts on actual application or use of our products. So there's a great number of resources there that span repair procedures in the industry and even into heavy duty truck as well. And that's also complete with some video trainings as well. Sean, if you would mind just going to the next one. And then, yeah, perfect. So another example of a resource that we've developed, and this has become really popular the last couple of years, and Jason Chardon, who's on here as well from 3M, has been an absolute champion in driving this and developing this resource for body shops out there, and that is the Collision Repair Materials Planner, something that we refer to as CRIMP. And in a nutshell, it's a web-based repair planning tool. The intention is to just deliver a process for shops to be able to measure, document, and then ultimately capture these required but not included in the process body repair materials. So, adhesives that Sean's mentioning, corrosion protection products like cavity wax, seam sealer, and many other products as well. We found that there are numerous benefits to this for shops, and that's certainly accuracy, transparency when communicating with whether it's the customer or the insurance company, definitely quality control, and then ultimately customer satisfaction throughout the process. So for more information on that, you can always contact your local 3M rep or ask your distributor to help you get in touch with them, because again, since we've launched this tool several years ago, it's really grown in popularity, and the industry has responded very well to the process that we can help you with. Jason, did you have anything to add to that? By all means,
Ian,
please.
Wrong Jason. Sorry. Go ahead.
Hey, either one.
Not too many of them online. So I'm Jason Chardon. As Ian was saying, we've got a lot of digital tools. The YouTube video channel is up right now. The Collision Repair Academy is our online e-learning platform that you can access straight from the 3M Collision webpage. But I also want to make a note, keep tabs on that webpage and maybe your social feeds, because the 3M Collision Repair Academy is also putting out live webcasts and virtual training as well. So we're trying to fill in these uncertain times with as much education as possible. So stay tuned.
Thank you. Thank you. And what you guys see here is just a couple of screenshots or thumbnail images from some of the new video content that we've released. And, you know, if you go to our YouTube page and just search or go to YouTube and just search 3M Collision Repair, you're going to find a ton of videos. We've been launching them since the beginning of the year. I think we've got 19 or 20 new videos up already. We should have 25 here in the next couple of weeks total, but you know, a lot of this is really OEM specific information, things like Sean has touched on here today. We actually have a lot of OEM seam sealer bead replication videos that are very OE specific. So, you know, common beads you might see on a Honda, Toyota, Dodge, etc. We've got some nice how-tos for you there. And then you'll find also, right, there's a number of topics that we're touching on, but a lot of how-to tips and tricks, even some pitfalls, things to look out for that are just inherent to some of the processes that our application engineers point out in those frequently asked questions. So if you guys go there, check it out. You, of course, can subscribe, and then you'll receive notifications in the future. And again, we've had some really nice engagement through this new video content out there, and nice response from technicians who are saying, oh, I had no idea that we could do this with your products. So go ahead and check that out, and I think you'll like it. And yeah.
I saw one of the questions was, how do you apply your 3M adhesive? So one of the new videos that we just made was kind of a 101 of panel bonding, and I do a live demo showing bonding like a frame rail together, and it goes through all of that step by step, all the details, and then we have a 201 that also includes sectioning, so working with the adhesives around that sectioning joint and things of that nature. So those are two of the videos that we just put out, so there is a lot of good stuff out there.
Yeah, head over there and check it out, guys. And then I just believe our last one here is something that Jason already made reference, Jason Chardon made reference to here just a moment ago, but that's the 3M Academy platform. Jason, I don't know if you had anything you wanted to add to that, or as a brief overview of what that program looks like.
So the 3M Collision Repair Academy is our online e-learning platform. To use it, you'll need to have your own individual login to the site, but it is free to use or to access. Currently, we have about 28 different courses on there, covering anywhere from body, metal department, paint, refinish, detailing, some front office stuff. So a lot of areas of the shop. 22 of those courses are currently no charge. Those are our 3M collision short courses. And then we have 6 online ICAR Alliance courses that are on there as well. So quite a lot of great content on there to keep learning while maybe we're not quite as busy as we could be.
To say the least, right?
Excellent. Hey, Sean, I've got a question for you. Actually, a couple questions.
Sure.
Can you just real quickly go back to your slide on the showing the linear feet on some of the on today's vehicles that are out there today with your ATS and CT6 and stuff like that? Real quick, if you wouldn't mind. Yeah, that one. So I think the increase or the significant increase in adhesives is kind of something that's kind of gone a little bit unnoticed by the industry as a whole. I think technicians probably are aware of it because they're working on vehicles every day. But so you've got, we lost it there. So like 400 plus linear feet on some of these vehicles, 264, 360, 591. How would that compare to a vehicle, say, that's maybe 10 years old?
As far as how much adhesive
Yeah, like
is in that vehicle?
the increase in adhesive used on today's vehicles versus a vehicle that's maybe 10 years old.
Yeah, something 10 years old. So we're talking 2010. A 10-year-old vehicle, I would say, you know, it's all over the board, right? It depends on the manufacturer, but I would say typically back then you're talking about 50, 60 linear feet on a vehicle. I know I had some slides in an older presentation that talked about that and referred to somewhere in that area. And and typically where you were seeing those adhesives were in the structural parts, in a lot of cases up in the front of that vehicle, in the frame rail areas and things of that nature. You didn't see as much of it on the quarter panels and those types of panels. So it was more in those structural areas where they were looking for a little extra strength, where they were well bonded from the factory. But yeah, quite a difference to what we're seeing now. And these numbers here are now, as we saw, very low. Even the 2016 at 591, we're seeing quite a bit more than that.
Yeah,
and again, it'll continue to grow.
Yeah, and again, those have been put there for corrosion resistance, for NVH assistance. So I think it's just important, again, as technicians, as collision repair professionals, that we're making sure that, one, we're fully aware of all those locations where the adhesive is, making sure we're accounting for that in our repair plan, make sure that we're putting those back in there. And then the follow-up question to that, Sean, kind of goes along the same line. A lot of times when I'm looking at those OEM procedures, not a lot of times, but often I'll see where it'll say, 8115 or equivalent. Give me your spiel on or equivalent, if you wouldn't mind quickly.
Right, and I did address that. I don't know if you missed that, but when you decide to use an equivalent, number one, I always kind of question, well, who told you that was equivalent? And a lot of times it's like, oh, a sales guy walked in the door and said, hey, this is the same thing, right? So be very cautious about that. But if you decide to use an equivalent, unless you have it in writing that adhesive is an equivalent, you are now taking on the role as the adhesive equivalency expert. So if it ever came to the ultimate situation where there was litigation and you were on a stand, I doubt if you'd want to take on that role as the equivalency expert. And like I said, a lot of these adhesives, it's almost like a fingerprint. They're so unique because of all the different chemicals that are in them, how those chemicals are added into the formula. And I mean, everything is very, very specific. So, and sometimes even looking at technical data sheets and comparing them and trying to compare all the, the lap shear strength and the age testing and the impact peel strength and all these, elastic modulus and all these numbers, it's almost impossible to determine that something is an exact equivalent. And you really don't see that terminology a lot. There's only a couple vehicle makers out there, or a handful that I'm aware of, that actually say or equivalent when it comes to the adhesives. You see that a lot with seam sealers and things that aren't as critical, but when it comes to the adhesives, they don't do that as often.
Okay. And we do have a couple other Q&As if you've got a few more minutes here. So
hey, I'll stay on as long as anyone wants.
Okay.
So
cool. So the first one is from Jody, and any good tricks for applying foams to make them expand better? And I'm gonna suggest that for this one, Jody, that we maybe go back to the 3M Academy, some of the videos that are on there, as well as Sean and Ryan and I had done a Collision Hub Technician 20 group a few months ago. It's on the Collision Hub YouTube page. If you want to go check that out. We did a lot of stuff on foams and kind of expansion of foams and things like that. So I'm going to suggest that you maybe go check that one out instead, rather than for today. And another question, Sean, we've got is, do you see in the future a vehicle being put together using super light but strong panels, all by adhesive bonding?
Yeah, I can see that happening. It sounds like maybe they're referring to carbon fiber or some other type of composite material. And what's interesting about that is when it comes to composites like carbon fiber or SMC or those types of materials, the adhesive is typically much stronger than the substrate itself. So they do use the adhesives in those cases a lot, because unlike with steel, where some, and depending on the thickness of the steel may be much stronger than the adhesive. So you have to really exercise caution on what adhesive you're using. But when the adhesive is going to be stronger than the substrate, and you're going to get delamination of the substrate, then it's a pretty easy choice to use those adhesives in that case. And I really think the trend for the near future in the next 10 years is still going to be kind of that hybrid design, where we're seeing a lot of vehicles with high strength steel inner structures, right? Where the tub of the car is still high strength steel. And then, other parts of the vehicle are where they're adding some other things. Like the CT6 is a good example with how they're still using high strength steel in like the floors and the bulkheads and the B-pillars, and then everything around that is aluminum. So I think we're going to see that kind of design where they're still going to be using high-strength steels and aluminum, and then a lot more outer panels and maybe like kind of those sub-inner panels that are composites and lightweight materials. I think we're going to see a lot more of the hybrids than completely composite vehicles.
Yeah, and I would echo that as well. I think we are going to see a lot more mixed material vehicles in the future. So we're not going to be dealing with, an aluminum intensive vehicle or a steel vehicle. It's going to be whatever materials that material engineer deemed appropriate for that particular application. So we are absolutely going to see more adhesives for repair, along with mechanical fasteners, whether that be rivets or bolts or some combination more than likely of it. But we're definitely going to see more adhesives in conjunction with mechanical fasteners moving forward. Another question for you, Sean. Is it important to check the temperature at which the adhesive is applied, or at what temperature is recommended for applying the adhesive?
Okay, so good question. We get that as it relates to different climates, especially like you're down in Texas in the summer, it changes everything, doesn't it? So you have a lot less working time. So I guess the answer here is that the 3M adhesives that we're talking about here today they operate in a wide range of temperatures, okay? The key caution temperature would probably be getting too cold, right? So if you get down below 40 degrees, it basically shuts off the chemical reaction. So you don't want to apply it or use it in a really cold environment, okay? It's going to take much longer to cure. And again, below 40, it may never cure, okay? So I would, recommend trying to use it as much as possible in that room temperature range, right? 70 degrees is really what our instructions are written for. And you may be aware of the 20-degree rule. So for every 20 degrees colder, it takes twice as long to get to that through that work time, right? And everything takes about twice as long. So I know one of the questions we get frequently is, hey, I am in Texas and it's really hot. It cures so quick. Is there anything I can do to slow that down? And yeah, you can cool that cartridge down. Okay, you don't want to get super cold. I would stay away from the refrigerator, kind of thing. That's pretty cold. But I would say, if you put it in an air-conditioned area, like an hour or so before you use it, you're going to get an extended working time. And it's going to warm up quickly as soon as you apply it to that joint, but it will give you a little extra working time. And then, try again, staying in that 70-degree range as much as possible. But you can also heat cure our adhesives. They're very forgiving with heat. So my personal recommendation with heating is 40 minutes at 150 degrees. So 150 degrees is not very aggressive, right? That's really like a black car in the Arizona sun gets up to 150 degrees. So 150 degrees isn't super aggressive, and 40 minutes isn't long to wait. And that gets you to almost full cure time, full cure strength. That gets you over 3,300 PSI of strength. So that's my recommendation for heating. But again, keep in mind that anything you heat, it goes by panel temperature, not the ambient air in your shop. And we all know that the bottom of the car is a lot cooler in a cool shop than the top of the car, So use an infrared thermometer or something and verify those temperatures of the panel itself.
What determines whether or not the galvanized coating needs to be removed, and has 3M done their own testing to see if there's a difference in the bond with or without galvanizing or zinc coating removed?
Another good question. So in the past, we had not really specified to remove the galvanized coating, but we are beginning to do that. And as a matter of fact, we I prefer to use the term apply it to bright steel. And that indicates once it's bright steel that the galvanizing is removed. And we addressed that in the videos that I couldn't play. We do talk about removing all the galvanizing, or in Honda's case, they use an aluminum coating, not a galvanizing, okay? And that's a whole different coating where it's kind of loads up paper, grinding discs a little bit, and it's pretty stubborn. So you want to get down to that bright, shiny steel. That's your best bet. If you apply it over galvanizing, that's kind of the weak link. I don't think there's a huge significant drop off, but just because there's different variables and different kinds of galvanized coatings, it's best to just remove it and get down to that bright steel where you don't have that additional variable in that bond.
Cool. And then one more before we close it out. Is there anything we should look at when referencing batch number info to see if it could be an expired product?
Yeah, not as much batch info, but just, use by date. And at 3M, we've transitioned recently from a Julian date that unless you know how to decipher it, it was a little confusing. But happily, I can tell you everyone in our lab is very happy that we're just moving towards an expiration date. Okay, so it'll be less confusing where it'll just say expires on. Okay, but some of the older products you may see where the first number is the year, and then the next three numbers are the day of the year. So the 156th day of the year or whatever. But the first number, if it was a 9, it would be 2019. Okay, so yeah, you definitely want to make sure that it's not expired. I know a lot of shops are actually documenting that for the file. They're making test welds through the adhesive. They're documenting the date of the cartridge, which cartridges it is, and which product it is, and even the temperature of the shop, whatever. They're documenting a lot of this stuff just to make sure that their bases are all covered. So the only time a batch number is important is really if something was to be wrong with the product itself. Then we can trace it back to that specific batch and find out if there was something wrong there.
All right,
Anything
then just one final comment. I definitely don't want to skip over this one. This is from Terry. As an instructor for a collision repair program, I want to thank 3M for letting my students in on the webinars and their donations to CREF, the Collision Repair Education Foundation. And Terry, I could not be a stronger advocate of a statement like that. 3M has done a tremendous amount for the Collision Repair Education Foundation, as well as the entire education industry for collision repair. They're massive supporters of Skills USA. I'm going to miss Sean and Mark and Dan and everybody, unfortunately, and we won't be going to Louisville this June. But they've done a tremendous amount with Skills USA as well. So I want to echo that as well, Terry. But yeah, so thank you 3M for all of your support of schools all across the country. So, all right.
Yeah,
Well,
we appreciate you joining us.
Yeah, absolutely. So with that, I want to thank everybody for your time this afternoon. Apologies for some of the technical glitches that we had. Sean and I worked on it this morning. We thought we had everything ironed out, but apparently that wasn't the case. Again, one of the drawbacks of doing some things live from time to time, but it gives a little more authenticity to it, I guess. So we'll be back at 1 o'clock this afternoon, with 1 o'clock Central Time this afternoon with Larry. Larry's going to be talking about estimating with nameplates and emblems. I'd be amazed at how much stuff that is out there that you might be missing when you're putting together repair plans for those in particular. And then at 3 o'clock, we've got Carl Liner coming in talking about, again, kind of a nice little segue from the adhesives into riveting and some of the mechanical fasteners, and talking about fastening technology for collision repair. So until then, again, thanks everybody for their time, and thank you, Sean, Ian, Jason, and the entire 3M team for everything. And we'll see you in a couple hours.